Imagine a mind wandering through internal landscapes, untethered by the present, freed from constraints, quietly simulating alternate futures, revisiting distant memories, or composing imaginary worlds. This drifting, often dismissed as distraction, may in fact be a hidden engine of human creativity. Welcome to the Science of Daydreaming, a cognitive frontier where spontaneous thought, default-made brain activity, and internal simulation converge to shape art, invention, and even scientific discovery. At first glance, daydreaming seems idle, a lapse in focus, an escape from the task at hand. But beneath the surface, the brain is anything but inactive. Modern neuroscience reveals that during these moments of so-called rest, a powerful network, the default mode network, DMN, lights up, composed of interconnected regions in the medial prefrontal cortex, posterior cingulate cortex, and angular gyrus. The DMN orchestrates mental time travel, self-reflection, imagination, and scenario building. In this internal theater, we rehearse possible futures, resolve past conflicts, and run complex simulations of social dynamics. The DMN does not shut down when the outside world dims. It begins to play. Here, the mind explores without agenda, generating strange juxtapositions, novel metaphors, and remote associations that the focused mind would overlook. This is not noise, it is pre-conscious creativity. Why does this matter for innovation? Because creativity does not always emerge from effortful thinking. It often arises from a delicate interplay between two cognitive modes, the task-positive executive control networks that drive focused work, and the DMN that fosters loose, free-form association. Creative insights, the eureka moments, frequently occur not at the desk, but in the shower, on a walk, or during a quiet reverie. These moments reflect a subconscious incubation process in which the mind reorganizes information, connects disparate ideas, and reframes problems in unexpected ways. How does daydreaming do this? One possibility is through conceptual blending, a spontaneous mixing of mental models that creates new patterns. Another is via stochastic resonance, where random mental fluctuations amplify weak signals into awareness. Daydreams allow the brain to break out of rigid routines and explore improbable, even absurd thought combinations. In this way, they become a sandbox for cognitive experimentation. But not all daydreams are alike. Research distinguishes between deliberate mind wandering, such as imagining a story or planning an invention, and spontaneous drift, where the mind meanders without awareness. Both have their roles. Deliberate daydreaming can extend working memory and problem solving, while spontaneous daydreaming may refresh the mind and generate novel combinations by bypassing filters of logic and inhibition. And the implications go far beyond creativity. Emerging studies suggest that adaptive daydreaming is linked to emotional regulation, resilience, and even moral reasoning. The same circuitry that supports creative imagination may also underpin empathy, allowing us to simulate others' experiences, anticipate consequences, and craft narratives that give meaning to our lives. Yet, like all powerful tools, daydreaming carries risks. Excessive rumination, anxiety spirals, or maladaptive fantasizing can hijack the DMN and lead to mental fatigue or disconnection. The key lies in balance, learning to harness the generative power of spontaneous thought without losing grip on the here and now. Can we enhance this capacity? Some researchers now explore how meditative practices, unstructured time, and even AI-assisted cognitive tools can support productive daydreaming. Imagine neural feedback devices that tune your mental state into the optimal zone for imaginative drift, or generative AI companions that nudge your thoughts just enough to trigger new perspectives, like muses made of algorithms. Education, too, is beginning to reconsider the role of mental drift. What if daydreaming were treated not as distraction, but as a core part of the creative learning process? What if students were guided not just in knowledge retention, but in imaginative rehearsal, where fantasy and critical thinking co-evolve? Ultimately, the science of daydreaming invites us to reframe what it means to be present. Perhaps presence is not merely attention to the external world, but also attunement to the internal. In this space, the mind travels through time, reconstructs identity, and seeds the future with unrealized ideas. The quiet moments we once overlooked may be among the most generative, transformative, and essential aspects of human cognition. Daydreaming, also called mind wandering, is a spontaneous shift of attention away from external tasks toward internally generated thoughts, images, and scenarios, engaging the brain's default mode network, a set of interconnected regions active during restful introspection and episodic memory retrieval. Rather than mere distraction, daydreaming occupies a spectrum from passive drifting to purposeful imagination and can occur up to half of waking hours. Neuroimaging shows that these internally focused states consume significant metabolic resources, indicating that daydreaming is a distinct and energetically demanding cognitive mode. During a routine commute, a person may unconsciously replay a conversation from the previous day and imagine alternative outcomes. It's like a computer running a background process that quietly simulates different scenarios while the main program appears idle. Daydreaming is characterized by decoupled attention from the immediate environment towards self-generated mental content, differing from focused imagination because it arises spontaneously rather than by intent, encompassing autobiographical planning, fantasy, and creative problem exploration that reflect an interplay of memory, prospection, and creative recombination. Psychologists distinguish daydreaming from rumination by its generally positive, flexible nature versus repetitive negative thought loops, and, as a ubiquitous mental phenomenon, it blurs boundaries between conscious and subconscious thought processes. A writer experiencing a sudden flood of story ideas while washing dishes is daydreaming, is like a radio scanning stations in the background, tuning into unexpected signals without deliberate control. The default mode network, DMN, including medial prefrontal cortex, posterior cingulate cortex, and angular gyrus, is reliably activated during mind wandering and daydreaming, with functional connectivity within the DMN correlating with the vividness and emotional richness of daydreams, while its dynamic interplay with executive networks modulates the balance between spontaneous thought and cognitive control. Neurotransmitter systems such as dopamine influence DMN activity, linking motivation and reward anticipation to daydream content, and dysregulation of DMN connectivity has been implicated in both creative insight and maladaptive rumination. fMRI studies show increased DMN activation when participants let their minds wander versus performing a demanding attention task. It's like a control room's monitors shifting focus from external surveillance cameras to internal system diagnostics when operations pause. Daydreaming facilitates divergent thinking by allowing the brain to freely recombine existing knowledge into novel associations without task constraints. And studies demonstrate that higher rates of spontaneous mind wandering predict superior performance on creativity tests, such as the alternate uses task. The incubation effect, where stepping away from a problem leads to insight, reflects the creative benefits of unconscious processing during daydreaming, making daydreaming a cognitive incubator that nurtures spontaneous idea generation. After taking a break from a challenging design problem, an engineer experiences a sudden aha solution while daydreaming on a park bench. It's like fermenting dough. Leaving the mixture alone allows natural processes to transform raw ingredients into something new. Beyond creativity, daydreaming supports autobiographical planning, goal setting, and emotional regulation by simulating future scenarios and rehearsing responses, enhancing problem solving through unconscious information processing, and boosting memory consolidation by reactivating neural patterns associated with learning. Positive daydreaming correlates with higher self-awareness and resilience, whereas structured mind wandering fosters adaptive reflection, underscoring daydreaming as a fundamental mechanism for mental preparation and growth rather than idle thought. Medical students who daydream about diagnosing patients show improved retention of clinical information. It's like running software simulations before launching a rocket to predict outcomes and optimize performance. Straight mind wandering varies widely. Some individuals spend up to 70% of waking hours daydreaming, whereas others maintain greater task focus, with higher propensity for positive future-oriented daydreaming correlating with creative achievement, while negative rumination associates with anxiety and depression. Personality traits such as openness to experience predict beneficial daydreaming, whereas high neuroticism predisposes to maladaptive thought loops. Understanding these differences enables personalized strategies to harness daydreaming for creativity while minimizing distraction. Writers scoring high on openness report frequent imaginative daydreams and greater creative output. It's like some people having a fertile internal garden for ideas while others contend with persistent weeds of worry. Excessive or negatively valenced daydreaming can impair attention, reduce task performance, and foster rumination that exacerbates mood disorders and mind wandering during critical tasks, e.g., driving, increases risk of accidents, highlighting the cost of unchecked internal focus. Chronic rumination reflects maladaptive daydreaming, characterized by intrusive, repetitive thoughts that undermine well-being, so balancing spontaneous imagination with executive control is essential to reap creative benefits without cognitive or emotional costs. Students who daydream excessively during lectures tend to score lower on exams. It's like letting the mind drift into stormy seas. Adventurous for sailors with skill, but dangerous for the unprepared. Techniques such as deliberate incubation breaks, mindfulness, informed mind wandering, and guided imagery channel daydreaming toward creative problem solving with scheduled creative breaks, encouraging intentional mind wandering in distraction-free settings to boost idea generation without impairing task performance. Journaling spontaneous thoughts captures fleeting insights before they vanish, integrating daydream content into actionable plans, and metacognitive awareness training helps individuals recognize and steer daydreaming away from rumination toward productive creativity. Designers using Pomodoro intervals incorporate 5-minute daydream breaks to spark novel product concepts. It's like giving plants periodic sunlight and water to flourish rather than letting them wilt in constant shade. Emerging research explores neurofeedback to optimize daydream states for enhanced creativity and mental health interventions targeting maladaptive rumination. Educational curricula may incorporate structured mind-wandering exercises to foster innovation and problem-solving in students. And workplace strategies that legitimize thinking time could transform productivity and employee satisfaction by leveraging daydreaming as a resource rather than distraction. Understanding the neuroscience of daydreaming promises new tools for unlocking human creativity and well-being. Pilot programs and creative agencies schedule inspiration hours for unguided reflection, yielding higher idea quality. It's like recognizing the power of idle steam in a locomotive. When harnessed correctly, it drives innovation instead of wasting energy.